C++ variables, functions, and classes are placed in a scope? Well, the meaning of this is that anything that has a name, like main, or pt, or point, or x and y, adjust, and everything else that you can see in here that has a name, also has a scope. And the scope originates in a place where the thing is first declared. So for instance, our main function is a global function because it resides in a global scope. It means that it's not part of any class or any other component of our program. On the other hand, variables such as x and y right here are member variables. So we say that they are placed in scope of class point. So they will exist in memory of every variable. Now, the issues of visibility suggest that if, for example, function is global, it should be visible everywhere. At the same time, the member function that takes two parameters x and y, or these double x and double y example here, these two arguments of a function, their visibility is local. They're only visible inside this function and nowhere else they would be accessible or even exist except when this function call takes place right here. So every object and every variable and everything that has a name has a scope, and the scope determines the visibility and lifetime of a variable. So this is very important because when we are trying to build the logic of our program, we have certain expectancy of a timeline of objects in memory. Example of a lifetime or life cycle of a variable would be this point object. It is a local object declared and instantiated part of a local scope of function main. So therefore, when function main ends right here, this object will be destroyed. So the life cycle in C++, the life cycle of every object and every variable that you create is predictable, and therefore this is important to understand all the rules associated with scopes, visibility, and life cycles of variables. So the C programming language, the predecessor of C++, comes with three types of scopes available to the programmer. The global scope, where I could declare a global variable like this. Local scope inside functions. Well, we have plenty of examples right here. So for instance, this object is local to function main. And code blocks also can have their own scope. So for example, if we have a loop of some sort, like a while loop, which is controlled by some sort of condition, and of course we create scope, we give this loop a scope, and if I declare a variable x right here in this loop, and something happens here, basically the life cycle or lifetime of this variable x is limited to the scope in which it was created. So the scope of x begins here and ends over here. It means that if I want to say something like x equals 5 outside of this loop, this will generate an error which will tell me that this variable is undefined because it has already being destroyed. So these are local scopes inside code blocks. So if one of the control structures have its own code block, then these rules apply. You can even have local code blocks without any control structures, just like this. if this happens, then once again the existence of this variable will be limited to this pair of brackets right here, which establish this code block. The code block is also known as a compound statement. Basically, you have multiple statements, but you can group them together and treat them as a single compound statement, and that would be also designated as a compound statement. So in C++, we also have classes, and classes, because the classes use these opening and closing braces, they also have a class scope. So the class scope can be referred to by name and using the operator like this, and it's called scope resolution operator. In our example, we already have it right here. When we define member function adjust, because it's part of, it was declared in class point, it belongs to the scope of point. So this is scope resolution operator that tells the compiler that adjust is a member function of something named point, and compiler already has processed this header file, so it already knows that point is a class, and class is a definition of a user-defined data type. So member functions themselves are in the class scope, obviously, and member function bodies have the local scope, which is just all the same for any function, for any other function in our project. Okay, so just highlights of what things are possible with scope. Well, you can use a typedef keyword to give an existing data type another name, create a synonym here. So because this typedef is placed inside class point, you can use an integer by using this data type point scope resolution operator coordinate. So this simply means that point defines coordinate to be a data type which is used for its coordinates. And you may be wondering, why not just use an integer over here? Yes, of course, we could replace this by an integer, but the reason for something like this is to it's a step in direction of generic programming, because in some other situation this typedef may change from integer to something else, like for instance a floating point or a double. And the rest of the code that's using this class, or otherwise is being used as a client of this class, their code should not need to change. So that is a step in this direction, and the typedef, of course, can be placed inside the scope. Enumerations can also be placed inside scopes of class. So that's an example where we have a new enumeration of constants first, second, third, and fourth. They will be automatically assigned integer constant values 0, 1, 2, and 3. And so from this point on, we could then use constructs like this to manipulate constants. Constants, of course, improve readability of our code. And we can have nested classes. So basically these are the classes declared inside existing classes. So here, for example, we can declare some other objects that are defined internally inside this class point. So that's not something that we're going to use very extensively, but don't be surprised sometimes to see another class declaration nested inside the existing class.